basically we are moving from our data validation, bolstering its value addition, or bolstering the artificial intelligence value addition through the AI algorithms, including the DVR. So this is our roadmap that we are planning to go ahead. So that is the fundamental platform on which we are basing this DVR summit in here. And we would also highlight our speakers in here, Devender and Nishant, who have been our flag bearers, and thanks in ton for their cooperation and support that made the project's immense success in Saudi Arabia and in days to come in the rest of the world.
So we have been for quite a few years focusing only on data reconciliation and validation, let's say. Well, we want to take it a step forward. So we need to help our customers use the data that we produce. We are claiming that we are producing reliable data, but we have observed that a lot of times the data just remains data. It's not fully exploited.
Okay. Good morning, everyone. I am Bassem Ali as a production planning engineer working for ERC, Egyptian Refining Company. First of all, I would like to express gratitude to Benoit and Antoine and all Bassem team who work on this project, ERC project. Second, I want to introduce to you the ERC project is a 4.3 billion greenfield refinery. It's a mega project. ERC is converting the lowest value fuel oil, which is AR, into middle and light distillate, with production capacity around 4.7 million ton of refined products. It includes 2.3 million ton Euro 5 diesel or low sulfur diesel, which represents 30 to 40% of Egyptian imports, and around 600 ton of jet fuel. Our feed mainly is AR, atmospheric residue, and natural gas, and our products is LPG, light naphtha, reformate, run with 102, jet fuel, diesel less than 10 ppm sulfur, and fuel oil, coke and sulfur. ERC is an integrated refinery, cooperating and coordinating with neighboring companies. The first company is called Cork, Carry Oil Refining Company, which supplies ERC with the AR as a feedstock. Then Gasco, this company supplies ERC with natural gas. Natural gas is the main feed to HPU, hydrogen production unit. And BBC company, BBC owns a huge tank farm. A portion of this tank farm are dedicated for ERC feedstock and final products. And we have also, Petrogas. Petrogas is receive ERC LPG production. This is the main unit for ERC, VDU, vacuum installation unit, and late cooking, DCU, hydrocracking unit, HCU, and hydrogen production unit, HPU, diesel hydrotreating unit, DHT, naphtha hydrotreating unit, NHT, reformer, CCR, regeneration unit, CCR reformer, sulfur recovery unit, and amine recovery unit, SRU and ARU. As we know, to monitor and control units KPIs and efficiency, capacity, and hydrocarbon loss, we need to implement mass balance calculation, which also helps to identify faulty flow meters or any degradation of equipment performance. So, to acquire a proper mass balance, data should be validated and reconciled. So ERC decided to get a DVR software to validate and reconcile the data generating during the measurements of the system, producing sets of data with increased accuracy and reliability. VALI software or DVR software with Bassem provides reconciled value for process units performance monitoring and intermediate products inventories, evaluation of design performance versus the actual one. Here we can see the main page for the software interface. So these blocks is the blocks for our units. This numbers of units. Unit 11, for example, is an HT. If we double click on it, here we have all streams in to the unit and all streams out from the unit. And we can show also the data from each stream, the measurement data and the reconciled data, comparing with the default or designed one. Also, VALI creates daily reports for overall mass balance and unit-wise mass balance, tanks inventory, and production accounting reports. Here we can see the example for the overall mass balance. It looks simple as shown. It contains all feedstock and product streams. It provides the total refinery loss, then divided into accounted and unaccounted loss, which helps us to improve the KPIs of the whole refinery. And here we have an example for VDU mass balance, example for unit-wise mass balance. We have here the capacity of the unit, and here we have all streams. Then, and in the same report, we have also the measurement of the volumetric flow meters, the used and reconciled one. Here we have data for the VDU, unit capacity, and or inlet and outlets, reconciled value as a mass, ton per day, with the yield of each product. And here we have the meters for volumetric flow meters for each stream, with measured and used and reconciled value for in and out streams, and also have density tags and density measurement for all stream. As I told you, VALI calculate the mass by using the volumetric flow meters and density tags, then calculate the mass. Here we have tank inventory report. This report includes all intermediate tanks in ERC. For example, TK5101 till TK5108B. Those tanks are intermediate tanks. We have here opening inventory and closing inventory, and also the percentage of the tank levels, and all data we can get from tanks. The last report is the daily production accounting report. It has all quantities in and out for the refinery, and all imports and exports quantity. If we have any difference between the imports and exports quantity, it can here find. You can find here the difference between, if there's a difference between any export and import quantity, it will be illustrated here.
Thank you.
Thank you,
Bassem.
Thank you.
We have a question here from Salah of Saudi Aramco. How could we reduce the unaccounted loss? This is the question. So probably Bassem and Benoit can answer this together.
Unaccounted loss, as it's said, is not accounted. And so, first of all, we have to either identify some part of the refinery that is producing some losses, and that we know from process engineering team that they are typical unaccounted loss that we can allocate in some part of the model. This is something that we have implemented in S-Oil project. I'm speaking about under their control. So what we do now is that unaccounted losses are generated by some part of the refinery where we can allocate some part of the losses. Okay, and so what we do now is that we implement some unaccounted losses streams in all units, and based on what is typically the loss that are reported from the process engineer, we can allocate some losses there. So the first thing to reduce unaccounted losses is to identify the place where they happen, and then we can try to reduce these losses.
Well, maybe I will complete your answer a little bit. In fact, the procedure should not stop, just at looking at one single run. What I would recommend is to look at trends. To investigate, and actually to convert, as you said, Benoit, more of these unaccounted losses into accounted losses. Of course, the second layer, you should reduce the losses altogether. Yeah, so once you identify the problems, you should act on them. Yeah, so this is what I recommend. So checking the trends, identifying the weak spots, and getting the information from it. It's of course particular to each case.
Yeah, case by
You
case.
should understand your process from the data, or the other way around as well.
Thank you. Thanks, Benoit and Lionel. And now we have one more question from Hijo Rayo from Soil Process Stream Innovation. May I ask, how much is your daily mass balance quality?
So we are usually around 0.5, 0.6, if I remember well, Bassem. And this is good to see any deviation from the usual trends. So yes, if the quality increase up to 1 or even 1.5, we can easily identify where there is a faulty flow meter, for example, or faulty density or anything, measurement, let's say. I think this is the numbers you have, Bassem.
Yes, it's around 0.4, 0.5.
Correct.
Okay.
May I ask Nishant also what quality he has?
Yeah, earlier, hello. Yeah, the quality, earlier we were closing around 1, but since the last 2 months, we have reduced below 0.5. So
Very nice, congratulations. Yeah.
Perfect.
So
Okay.
this is based on, the subsequent runs that we are doing. So that's why now I have one, something related to the unaccounted. You are discussing like that. No, in the unaccounted part, there are a few things like, first you need to see that if a model is properly built, some of the streams are not included, that needs to be properly checked. So we had re-reviewed the model with one of the unit where the unaccounted loss was higher. So this can be done with other places where the DVR has been installed. You can check the modeling part. You can see that if any streams are missing in there. So that is one thing, and we have checked where there are some leakages or some streams which are NNF, which is already closed. It is not passing or something like that. So we are in process of doing all these things. So we can come up with some better,
This is what I was saying. So let the data drive the process. Tell you about the process, and the process telling you about the data.
Both in sync.
I think this is the correct way to go and reduce this unaccounted losses.
Yeah. So I think we are a bit pressed on time. So let's move on to. I have a question from Mr. J. Park on the difficulty on the redundancies of the project data. But I think we can hold on.
Just 1 second. I would like to make one small remark here. So do not forget that we also offer energy performance monitoring, not only mass balance. Yeah. So please feel free to come up with questions on all fields. Go on, Surya.
Yes. So now I'm just going to bring the focus onto the energy-related projects and the performance of those projects. And then we could address this question from Mr. J. Park as well along in terms of the redundancy of data and the management of this information. So may I request Devender Singh of Saudi Aramco, who has been our focal point and instrumental in delivering numerous projects in terms of his technical knowledge and coordination and the liaising activities. Without him, it would have been nearly impossible to execute any project in there. So I would ask Devender Singh to say a few words about the technology, the challenges he faced, and what he would recommend to include in upcoming VALI versions.
Basically, VALI, I love this software technology because it brings so many things on the table, and it basically needs a whole process engineering team to understand the results and how you can use those results to improve the performance of your refinery. Whether it is mass balance, whether it is energy balance, it brings a lot of information on table. The thing is that it's still sometimes we face challenge to exploit the results. So when you talk about AI. I think the need is that we should get some kind of advisories, automatic advisories that what we should do, because Valley generates very high quality data. So if you have exchangers, if you have compressors, and you have different efficiencies, you have different operating modes, it can bring you so many things on the table. And recently, I was supporting one of the refinery on East End, and they were also, I mean, they have also seen the power of Valley. So, I mean, this is what I have to say. And at Saudi Aramco, I mean, these are my views. I do not represent. They may not be the view of Saudi Aramco, but
Yeah.
to the best of my understanding, the company also has appreciated the results.
Thank you. Thanks so much, Devender. And let's just to add something in line what Devender has requested, that it should have some sort of a decision support system, or in terms of insight provisions. So Valley itself provides insights, but what you say, the quantification and action related recommendations are all in pipeline using AI and optimization pursuits that are coming into the software right now. So we have optimization included right now. AI bridging is underway. So we look forward to meet and deliver to your requirements and expectations in very near time to come.
Yeah, I'm actually very excited to hear that actually this kind of things, it's exactly what we are looking for. Well, we are also engineers, right? So we face the same kind of issues. When you have 8,000 tags, it's difficult to focus on all of them.
Yeah.
So we are working on developing this tool, to get your attention. So you do not need to get one equipment that is running fine. Do you agree? So it's not so much interest to necessarily say, yeah, this is going okay. But when you have a problem, to be directed towards that problem. So this is what we were talking about, predictive data analysis. So I hope this will fulfill your needs. Look, we have this question from Mr. Park.
Yes, so let's come back to the question from Mr. J. Park. Have you faced any difficulties of lack of redundancies during the project? And if any, how do you manage those issues?
Well, me, I would say one thing which is general. So I'm not referring to a specific application, but miracles cannot be done. But what happens if you do a simulation model? So you have to plug in some data. So if you do not have sensors, you have two options: you put sensors, or you supply the information yourself. And we know this is one of the troubles, because what happens, even if a model has a lot of redundancies, you might have sections, areas in the model where the redundancies is less. So because we need to compromise on this kind of models, with mass balance, well, where there is no redundancy or there is no data, the engineering knowledge should come into place. This is what I always recommend. Do not forget, the results of whatever model you have are dependent in a certain measure on the engineer that handles the application.
To answer specifically on the ERC project, it is a new refinery. It is a new refinery where there are mass balance flow meter at the battery limit of the refinery, where all at the battery limit of all units there are standardized flow meter that are redundant with the main flow meter of each unit, etc. So, Mr. Park, we did not face this kind of issues of lack of redundancy for this specific ERC project.
So when you have these information redundancy related issues, what we can offer or say on a blind note is, of course, we need data to go ahead and reconcile, but having nothing and having something converting to your 60% of your requirement through thermodynamics, energy balance, and mass balance equations is what we offer. So if one sensor is coming in and 3 sensors are going out, you don't measure 2. We have to either try to have an assumption in place or have to back calculate using the downstream equations, or we go ahead and put an assumption at the last point if that is not possible. But these assumptions are anyway cross-checked and validated, and you can have some hypothesis testing through our advanced statistics and analytics models to see whether your assumptions are making sense or they are causing the problem. So that is where we challenge your assumptions when there is no redundancy. If you put an assumption, those assumptions could be challenged. But the first is, if you can measure something, don't estimate. If you can estimate something, don't assume. And if you cannot do anything, then just assume. So this is the path we follow.
Exactly. This is the point. I mean, miracles cannot just happen.
Hello, can I add something here?
Yes, please.
Go on.
Yeah. And we had faced this kind of issues, like somewhere there are lack of redundancies and all these things. So for these, what we did, some based on some design process data and all these things, you can have some calculations and freeze some value based on some pi tags which have the real-time values, and you can prepare an equation and you can create another pi tag that can be fetched into the model. So these kind of things can be done.
We can also use correlations.
Correlations, exactly. We had, in the slopes measurement, we do not have proper measurement. So, we have used the pump start-stop operation to generate the figure of slopes generation. And this kind of equation we have fetched into the pi, and that we can, add into the model. So these kind of things can be done to have better redundancy. That's it. Otherwise, you have to live without the data. You can assume something. You can go with either this meter is saying better or this tank is more reliable. You can have that assumptions.
Okay,
that's it.
Yeah, it's totally correct what you say.
Can we listen?
I think, look, maybe we keep you a little bit longer, but I think Nicholas wants to make some remarks with respect to well, he has quite a lot of experience in implementing these mass balance projects, and I think he has a few comments on unaccounted losses and quality of models, especially with reference to the last implementation in SOI. Nicholas already sent me some comments. Okay. So the first one, it's I think in line with what we were saying, that actually with the unaccounted loss, well, first we need to try to identify as much of these losses as possible. So that's why we have VALI, because we have the possibility to analyze the data resulted, and you can come back in the model and retune and modify to account for this. So you can actually come up with better assumptions. You can validate, you can refine these assumptions so that your numbers are brought down. Anyway, what he says is that the assumptions have always to be tested. Then there is a remark about the quality of the model in SOIL, that there are quite a big difference between Petro Rabigh and SOIL. Well, Petro Rabigh and maybe ERC and SOIL is because there is a different approach. So there is volume and density in this model, while Petro Rabigh uses mass directly. So yeah, it can have a big impact because of the systematic errors that you can expect in such an approach. I think, Surya, we have some questions on the chat.
Yes, just there. So the answer from Mr. J. Park is, thank you for the answer. Reason for this question is it's difficult to estimate when enough measurements are not available. But with thermodynamics, we have reasonable confidence of estimation, and we could cross-check those assumptions during the calculation. Next, going forward, is Mr. Jongo Park. The reports are not coming out systematically. It is just made with many data in SQL database. So whenever the model is modified, it requires a lot of labor. Do you have any plans to improve the Excel-based reports?
Definitely. That's what we were saying, and not only Excel-based. Well, Excel, it's addressed to engineers. So let's be very, very clear. So Excel, you want to have the data and to play with it. Now we're working also on a tool to have this, as Nishant also stressed out, to have this automated reported, and with a different interface. Not necessarily you need to open the Excel and activate the VALI report and do all the base there. We're let's say well started on this.